Alrighty, this is my 1.2 starter project. Sorry this is late, we ran into some issues, but most of it's been sorted out. So for the custom map we just popped into landscape and I added some mountains and I created some foliage using some Unreal assets from the marketplace. For imported objects, I just grabbed some objects from a few of my previous classes here at UAT. If it'll load, there we go. Just some things I created for a medieval scene, so these lamps, a little bit of ruins, a door, a bench, sword and shield, the well, and we separated the textures and the materials. And for my simple reusable blueprint actor, we just followed the example, which was the welcome string, so when you hit play, it's taking a minute to load, there we go. Hello, welcome to my game in the top left there. Alrighty, for the principles of OOP, we have to start off, we have abstraction, which you can see with the move and sphere blueprint here. Basically, if you don't necessarily need to know what all the code does. You just need to know when this action occurs, this one will happen in turn. So, event actor begin overlap. All you need to know is that it will destroy the sphere, and the actual code is hidden inside the function. For polymorphism, it's basically just you can have different names for the same kind of thing almost. Like the example given in the assignment is, opening something. Opening something is different depending on if it's a door, a letter, a window, stuff like that. Don't really have any examples of that in the project right now, but we might get some more down the road. For encapsulation, encapsulation is basically making sure that all of the code needed for a blueprint or a type of object is all within that object. So an example of that would be all of the move-in object information is encapsulated in the move-in objects folder in these spheres. And for inheritance, that's basically just code that is given to one main actor and then having children of that actor, so it is all the same stored information, but you don't have to rewrite it for everything. We have something kind of like that in my assignment with the move-in sphere, because all of the code from the move-in sphere is what is used for the flee-in sphere and the chase-in sphere. Although they're not technically inherited objects because I needed to change the code, so these are actually duplicated objects. So for both vectoring and for the movement of the actors, we'll use the move-in sphere as the example. For vector math, it's basically just math. It's just adding different values or subtracting them or multiplying them or dividing them to get the information necessary to plug into the blueprint. So the example for the movement would be we get the player pawn, which is the character, get its location, and then you subtract it from where the moving sphere is. You then normalize this value. We'll skip this part right now because that's for determining time. And now you have the difference between where the actor is and where it isn't. You can get the location of the moving sphere, and whatever the distance is, it will add it together and it will try to move to that location. For our variable, we have a speed variable in all of the spheres. So we have the one in the fleeing sphere here, which is 50. These are exposed variables, so they can be changed in the actual player. It's 50 there, and it's 430 for the chasing sphere, and 430 is the base value just across all moving spheres until you change it. Alrighty, and for the differences between time rate and frame rate, is basically instead of reading it as every tick will not be registered as a frame, it will be registered as a second. This is to avoid any errors where you have a low frame rate and something is not happening as often as it should happen. How you do this is fairly simple. You'll take the delta seconds and then you'll multiply it by your speed value. This can be a different variable if you want it to. And then you will punch it into your equation. So right here we're doing it after the normalize to combine this information, so that the actual blueprint understands we're not doing by second, or we're not doing by frame rate, we're going by seconds. So we have both hit and overlap events in the project. We have, for the fleeing sphere, we use a hit marker. This is so it can be destroyed by the player character as well, or only by the player character, because there's some weird things that'll happen if both objects overlap. So the event hit, it's just when the fleeing sphere gets hit, it will blow up, it'll spawn the blueprint explosion effect, and it will destroy the actor. And for the chasing sphere, it's the same general thing, except it's on overlap. So event begin overlap. When this overlaps a object that is either the fleeing sphere or the player character, it will blow up and will spawn the little effect here and will destroy the actor. I can give an example of this in the player. Let me run around here. And there we go. Sorry if that was a little loud. Alrighty, and for player inputs, we have a few different ones. I'll open up the player here. So we have, for the third person character, we have a few different ones. I created this one, which is just when you press P, the player will crouch, but because we don't have the any states set up for that yet, right now all it does, just to show it's functioning, is it will print a string saying I am now crouching, and it will, when released, print the string I am not crouching. So I can show that real quick. I am now crouching, I am not crouching. For the other variable, or the other key inputs we have 0 when, or not 0, we have O. When O is pressed, it will spawn a fleeing sphere, and we use the vector variable here just to spawn it this distance away from the player. And when you press I, it will spawn a chasing sphere at this distance away from the player. So I'll demonstrate that as well. When we press O, we get a new fleeing sphere, and when we press I, we get another chasing sphere. Now for the difference between is key input down and just a normal key action, I believe the difference is just if there is any effect when you release the held down keys. So in this case, the 0 is not a is input key down, it is just an input key, because when you press it, it will spawn this actor, it does nothing if you release it. Whereas P would be is input key down, because when you release the key, it will do something different. And the 0 key and the I key are just both showing that we have blueprint functionality for spawning actors, and the fleeing sphere and the chasing sphere show we have functionality for destroying said actors as well. And also technically spawning them in as well, because this creates an explosion effect as well. So that's where the project is at right now. I would like to continue working on it and do some more work, but for the time being, this is the extent of the functionality of the project.